I'm Pfrang. I'm Professor of Atmospheric Science at the University of Birmingham. I have a broad interest of research. More recently, I've moved into trying to understand indoor air quality, which is a very important topic. It has only been recently recognized as a major challenge, largely caused by the COVID lockdowns, realizing that we spend so much time indoors, 80 to 90% on average for a UK population. And I think it's really amazing how little we know about the indoor air. How little we know about what I'm breathing right now, because in many locations, first of all, there are no measurements, there is no understanding how air moves in indoor spaces, and also there's very little regulations, especially in private homes.
We have become much better at insulating our environments, and this is a very nice thing, but by insulating the indoor environment from the outdoor, and kind of short-circuiting this connection, what we might be doing as well is keeping some pollutants that we produce indoors in the environment and not exchanging sufficiently. And we might be exposed to those pollutants more than we need to. We cannot keep assuming that pollution or bad air quality in indoor environments is something inevitable. So there is an element of health inequality here, and again, the data are very clear on this. It's a stark contrast, even in developed countries like the UK. So that proves that there are material conditions we can act upon, and those have to do with environment outdoors, of course, having more green areas, being less exposed to heavy traffic and so forth, but also with environment indoors.
This project is called the Indoor Air Quality Emissions and Modeling System, IAQ EMS, which has been funded by the MetOffice and UKRI. And it involves a range of scientists here at the University of Birmingham, but also at Cranfield University and Cardiff.
The Clean Air programme is part of a Strategic Priority Fund programme that the MetOffice have been involved with for the last few years. And it's a very good research programme in that it allows us to approach developing solutions for environmental problems in a much more holistic fashion that has been done in the past.
So as part of this project, we have three key outputs. And the second output is led by Bruño Fraga here at Birmingham, looking at high spatial and temporal resolution modeling of the chemistry and the transport of pollutants indoors.
The goal of the project is to generate two different models. One is what we call a specialist model, and that is my task. The name of the specialist model is ChemFlow 3D. The specialist model is designed for researchers and for people who work in the MetOffice, so they are used to work with computational models. It provides a lot of information. You can basically recreate, sort of like in a video game, you can recreate a room or a floor plan, and then you can recreate sources of pollution, sources of emission, right? And see how they evolve in space and time. And this is something fundamental because we want to understand better the space-time evolution of these pollutants in order to understand better also, first of all, what is our exposure to them and how we can more effectively remove them from the environment. So usually, physics and chemistry are solved separately. But in this case, we decided that it was very important in seeing the evolution in time and space of the pollutants to also see how they react with each other. Sometimes they will form secondary pollutants that weren't there in the first place. This is rather important. It's something that we didn't want to ignore. And our model couples that with the physics. To couple that explicitly, all in the same model, for the purpose of air quality indoors is something that hadn't been done before. And it was a real challenge. And we are very proud of what we achieved with ChemFlow 3D. And this is a work I supervise and developed with my postdoc, Zhen Liu. She carried out most of the simulations, and we are very happy with the results.
And the third output we are developing is a multi-box model system, where the aim is to be able to describe any building of any complexity and the transport from one room to another and to another story to understand how pollution travels. And that work is led by Roberto Sommariva here at Birmingham as well.
Then there is another model, and this is what we call the non-specialist model, which is called MBM-Flex. It was led by James Levine and is now led by Roberto Sommariva. And this model incorporates simplified circulation of air between different rooms and also includes the chemical reactions that may happen between those pollutants. It is very useful for us researchers to have very advanced tools that provide us a lot of information, but another critical aspect in something that has such a societal impact is knowledge transfer. So we want to provide them with a model that provides quick, easy, accurate information, perhaps not with the same level of detail, but something that critically improves what they had before.
So these three outputs are very closely linked by the measurement campaign that we've undertaken as part of this project, where we used high quality instrumentation to actually go into, for example, people's homes and measure what is the real pollution in a kitchen, for example. This is particularly important because we know very little about pollution in private homes. There are very few regulations and people do all sorts of things. They are obviously cooking, they are cleaning, they use personal care products. Depending on the choice, they might have quite a good air quality or a really poor level of air pollution that substantially elevates their exposure to pollutants.
Modeling helps us understand things that already happened, but the ultimate goal is to predict things that didn't happen. If we are talking about indoor spaces, that allows us to design more effectively indoor spaces, to design more effectively ventilation system or heating systems in ways that allow us to keep a good air quality and also good thermal comfort and good energy efficiency, because we want to make this compatible with as a high level of sustainability as possible.
This project has been really an eye-opener for me personally, but also learning more about the remaining challenges in indoor air quality specifically. So we've developed some outputs, but very clearly these outputs show that there are huge knowledge gaps remaining. In terms of the model outputs that we've developed, we have applied them to a very small number of locations. And we really would like these to be used by researchers to apply in different locations. Not a single project can address that. And then the multi-box model, we really would like practitioners to use more frequently. So I'm thinking about architects or city planners and councillors making decisions about, how is the city of the future looking like? Because it's really important to have an understanding of what impact do decisions have on indoor air quality, because in the end, the exposure of people in new spaces should be minimal in terms of air pollution, and our models can really help to achieve that goal.